Hello, welcome back, students, everyone. I welcome you all. In the previous video, we have, in the previous lecture, I can say we have started a topic of the class ninth of the physics, very first chapter of the NCRT for the physics, that is the motion. We will make a little recap. We first described motion. An object is said to be in motion when it continuously changes its position with respect to the surroundings and with respect to time. So when we have these things, we say that the body is in motion, and we define the motion in the different perspective. That is when the coordinates of the body change with time, and we define rest also, and also the point of frame of reference, sorry, and different types of motion also. And in this chapter, we have a straight line motion as per prescribed by the NCRT. Describe the type of quantities. Now we are going to define the this. I'm trying to zoom in here. The motion along a straight line. We will define this topic in a few minutes without boring you more. I hope you will enjoy this and understand this thing. Without, you can comment me in the comment section if you have any doubt, or if you need any assistance regarding this lecture, regarding any other subject like chemistry, maths. You can give me a comment for that, and do share and subscribe this channel, please, and like the channel, like the video if you like. And if you want any rectification in any of the lectures, you can directly comment me without hesitation. I won't bother it, because life is full of learning. So that मैं भी आपसे कुछ सीखूंगा, I can learn and I will try to adopt that thing. So without wasting much more time, we will try to understand what does this term mean. I, as the name suggests, its name suggests that motion that is along a straight line. So when a body, suppose if we will take a body, I have two paths here. One is O A, another is O. Oh, sorry, I will try to draw it in the next page. Suppose this is the body O A. This OA is the path, and that is X. Now, if a body continuously moves along this path, and it does not change its angle, continuously move along a straight path, then we can say that body is in body is in motion, that is a straight line motion. Or we can say another term used for this is linear motion. You will go to in detail in the types of motion, like angular motion is there in the upcoming class, that is class 11th. You can go through the NCRT textbook of the class 11th, and you will go through all the types of motion there. Here we have a simple टॉपिक, एक छोटा सा टॉपिक है मोशन अलोंग ए स्ट्रेट लाइन. इसका दूसरा नाम इट्स लीनियर मोशन. सो व्हेन द बॉडी डज नॉट make or does not change its angle while moving from one place to another place. Suppose if it is moving along a horizontal line and continuously to move in the horizontal line, sometimes it can go parallel, it can go vertical, but not changing its angle like this. we can see a body continuously rotating in a circular path is having angle at different points. Suppose if this position was this, we can change different colors. Here it is this, and it is continuously changing its angle. So this is another type of motion which we need to learn in the class 11. Now you might be thinking that why I have opened this NCRT book here. I would like to recommend to all of the students, don't go through any heavy or bulky references which waste a lot of time and does not give a precise concept. Rather than, if you will go through this NCRT textbook, you will be very much puzzled when you will go through this, because it has mentioned that topics which none of the none of the reference books has has discussed. Now I will try to explain the new thing which is in this topic, that is distance and displacement. Sorry, there's a mistake in the confusion. Displacement. So what are these two things? As we have already gone through the two quantities, that is vector and scalar. These quantities are related to these two quantities, vector quantity. And first we will go through this example. Suppose if we have a body, if we will start at this point, this is point O, then we have a 5, 10, 15, 20, 30, 25, 30, 35, 40, 45, 50, then 60. This is a path. We are taking a body, suppose X, and it is moving through this path, and we have here cited three instants A, B, and C. A is at this point, B is at 35, and C is at 25. So what is saying that if a body moves through a C, moves through first C, then B, and reaches A. So the total path he covered is OC plus CB plus BA, and this is in kilometers. If we will look at this, and we will get a total distance of 60 kilometers in this first path, and then reaches again, it is coming back again and reaches to C. First the direction of a motion was in this direction, and now the direction is in this direction, right and left, and then reach again AC. We will go from this up to here, we have 30, and this is 35 kilometers, and we will add it OA plus AC. Have some patience, guys, this is very crucial topic, you need to understand this. OA plus AC is 60 plus 35. So the total distance covered by the body is 95 kilometers. You will not find this kind of example in any of the reference books to understand the concept of a distance and displacement. So try to concentrate over this. So this is the body it reached from O to A to B, and B to C. So this is the distance covered by the body, and this is known as the this. Now, in order to define the distance, we only need its numerical value. Numerical value is what? That is magnitude. And the quantity which is having a magnitude only is a scalar quantity we discussed in the previous lecture. He has mentioned here, to describe the distance we don't need to specify only we need to specify only numerical value, not the direction of a motion. There are certain quantities which are described by specifying only their numerical values. The numerical value of a physical quantity is its magnitude. So the quantity having a magnitude only, but not particular direction. Here the body is having multiple directions going from O to A to B. You can look here, O to A, and A to B, O to C. They are having a different directions. So the body having n number of directions, not a particular direction. Then the quantity is a scalar quantity, and this type of a quantity is this is a we term this distance. Now, if we will move further, the numerical value of a physical quantity is magnitude. From this example, we can you find out the distance of a final position C of the object from the initial point. Oh, the difference will give you a numerical value of a. Suppose it is saying, we will try to understand. The numerical value of a physical quantity is its magnitude. From this example, can you find out the distance of a position? Distance of the final position C of the object from the initial position. So he is trying to say that, can you find the position of a body when it is at C from O? So the difference will give us the answer. This difference of what? Difference of final position minus initial position. This thing is called as displacement. So what actually displacement is? Shortest distance measured from the initial to the final position of an object. Shortest distance measured from initial to the final position of object. When we have a shortest path, or we can say the final position minus the initial position, or we can say from the initial to the final position of the body, that quantity is known as displacement. So it is asking a question here now, can a displacement be equal to distance traveled by the object? So he is asking us, can a distance and displacement have the same magnitude? So he is considering an example again. Consider an example given in the figure. For the motion, suppose if we will look here, distance from O to A, when we will go from this point to this point, the distance covered is 60 kilometers, and the magnitude of displacement is also 60 kilometers. During its motion from O to A and back A to and back to B, the distance covered here is 60 plus 25 kilometers, that is 85 kilometers. While the magnitude of displacement is only 35 kilometers. What he is trying to actually say, that when a body moves from O to A plus A to B, here O to A was 60 kilometers and then A to B was 35 kilometers, and it is exactly equal to 25 kilometers, 85 kilometers. This is the magnitude of distance. Magnitude of distance is 85 kilometers. So the question was, can the magnitude of distance will be equal to magnitude of displacement? We need to find this, and he is trying to make us understand through this example. If a body goes from O to A and A to B, what will be the magnitude of displacement and what will be the magnitude of distance? Will both be equal? The answer is no. Why? First, we will see the value of a distance. Actually, in the one more definition which I try to add here for the distance is the total path covered by the body. डिस्टेंस के लिए हम ये यूज कर सकते हैं टोटल path covered by body, क्योंकि when we saw here, when the body moved from O to A and O to A, then A to B, then B to C. If we will add up these things, this was the 95 kilometer. So we said that this is the distance, this is the value of a distance. Actually, we are adding up the paths which are traveled by the body. So we are taking the sum of the values. So this is the total path covered by the body. I hope you got it. Now the question which was asked by the NCERT was that can the displacement and the distance magnitude be equal? We choose this example that body moved from O to A and A to B. What is the magnitude? Magnitude of O to A, I'll choose a different color. O to magnitude of O to A plus A to B is equal to 85 kilometers. This was the magnitude of what? Distance. And this is the, again we'll recall this concept, this is the total path covered by the body. And what we said about the displacement is that final position minus initial position. So what is the final position of the body here? Final position is at 25 kilometers. And what was the initial? 0. Here it is 0. And 25 minus 0 is 0. Magnitude of OC is 25 minus 0. It is 25 kilometers. So the magnitude of distance is not equal to magnitude of displacement. So at the point C, the magnitude was 25 kilometers. Both the magnitudes are not equal. One more thing that we try to distinguish here is between distance and displacement. Sorry. The first point is distance is scalar quantity, and this is vector quantity. Second thing, it is total path covered, from where we can get the value for displacement, that is final minus initial positions or shortest path. Second thing, distance can never be zero. Can displacement be zero? Yes, we will define that. It can be zero. It is always positive. It can be positive, negative, or zero. These are the final drafts of the distance and the displacement. Here it is NCRT, as per NCRT, displacement of course of a motion may be zero, but corresponding distance is covered is not zero. If we consider that object travels back to, we will go, this is the final point of this lecture, that if suppose the object first moves from O to A to B, B to C. Now if we will say that C to O, this is O to A plus A to O. What is the total magnitude of a distance? That is 120 kilometers. But what about the displacement? Final position is 0. Initial position is 0. That is the 0. So displacement here is 0. Thank you so much. Kindly comment your views or questions, whatever you have. If you have any doubt, I will repeat or I will make another example to understand this. Thank you so much.